In example 4, we'll learn another trick in terms of simplifying, or later for when we verify. It says rewrite 1 over 1 plus cosine x as an expression that does not involve a fraction. Now, what you want to think about as you're looking at this 1 plus cosine x, and a lot of people start to think about their Pythagorean identities. But because that cosine is not squared, there's no Pythagorean identity that we can use. And there's really nothing we can change the cosine into to make this any easier. So what we're going to do is is the trick of multiplying by what we call the conjugate. So let's write that down over here. We need to multiply both numerator and denominator by the conjugate. The conjugate is just when you take the term that you have, this 1 plus cosine x, and you change the middle sign. So if it started out as a plus, the conjugate would be a minus. And if you started with a minus, the conjugate then would be a plus. Since we have 1 plus cosine, we are going to multiply by the conjugate, which would be 1 minus cosine x. So what we have originally is we have 1 over 1 plus cosine of x. And what we're going to do is we're going to multiply by that conjugate. So that means we're going to multiply by 1 minus cosine of x over 1 minus cosine of x. We can multiply by the same thing over itself because this fraction right here is just 1. And multiplying something by 1 doesn't change the value of what we started with. And then what's going to happen is if we multiply across on the top, we get 1 times 1, which is 1, and then 1 times negative cosine, which is negative cosine x. And in my denominator, you should notice that you have a difference of squares now. We have 1 plus cosine x, 1 minus cosine x. Like I said in the past, if you can't multiply those together or you don't recognize the difference of squares, you can always go and multiply them out on the side. So you could take the 1 plus cosine x times 1 minus cosine x and go through that multiplication. So 1 times cosine, 1 times 1, 1 times cosine, cosine times 1, cosine times negative cosine, and simplify from there. But if you do recognize this now as a difference of squares, you should know that in the end, after you do all this multiplication, it simplifies down to 1 minus cosine squared x. And then 1 minus cosine squared x, now that we have this squared up here, now we can start thinking about our Pythagorean identity. And remember that Pythagorean identity was sine squared x plus cosine squared x is equal to 1. And if I want 1 minus cosine squared x, I'm just subtracting the cosine squared over, which is the same as sine squared. So I know sine squared x is equal to 1 minus cosine squared x. So I'm going to make that substitution. And I get 1 minus cosine of x over sine squared x. And then from here, there's really nothing I can change sine squared to in terms of cosine unless I go right back to the step that I had prior, which doesn't really help me out. But there is a trick that you can use as you go through some of these problems, where if you have one thing in the denominator, you can split that up. So because I have the sine squared here, I can put the sine squared with both of these fractions. So I want you to think about something really quick before we get to that, just so you understand what I'm talking about. If I have 3 over 2 plus 5 over 2, and I add those together, I get 3 plus 5 over 2. And all I'm showing you is that if you have something like this, you can go backwards and split them back up again. You can take both things that are in the numerator and you can make them their own separate fractions because they both have the same denominator. This is the concept that we're going to use right here to split up this fraction. So because we have the 1 and the cosine over sine squared, both the 1 and the cosine take that sine squared as its denominator, just like the 3 and the 5 took the 2 as its denominator. And we can split it up as 1 over sine squared x minus cosine of x over sine squared x. Now 1 over sine squared x, we can just do the reciprocal, which is cosecant squared x. And then we have this minus cosine over sine. Well, that one's not quite, we can't say tangent squared or cotangent squared, sorry, cotangent squared, because this one's not squared, but this one is. But because we have this fraction, we can also do another little trick, which is to split this up. And since it's being multiplied together, we can do cosine of x, and let me get some room over here. So we could do cosine of x over 1, or I'm sorry, over sine of x, times 1 over sine of x. So what I've done is I've split up that sine squared, and because we're multiplying, again, it's different than what we did from here to here, because this was subtraction that we split up. This we're just talking about splitting up one simple fraction of multiplication. So if I multiply this back together, cosine times 1 is cosine, sine times sine is sine squared. But now I have two individual functions that I can look at. Keeping my cosecant squared x first. Now I have cosine over sine, which is cotangent of x. So minus cotangent of x. And then I have 1 over sine of x, which is a cosecant of x. And now I've gotten this down to where I have no fractions anymore. If you have questions, let me know. Otherwise, you can go on to the try this. It is going to be a separate link, so you can go ahead and click on that link.